Wow, this worked so much better than I thought. Nice. Hello everyone and welcome to another video. Today we have a motherboard here that needs some restoration, and this is the P5A-B in revision 1.03 from ASUS. This is a Super Socket 7 motherboard and it has some issues. Well, for starters, we don't have a socket. We do have the metal pins though, so I have no idea what happened to the plastic socket. I found it like this at the scrapyard. So yeah, it just came like this, and we only have the pins that are usually inside a plastic socket. But there are more issues. We'll look at this under the microscope. There were some modifications done on the power supply connector here. I don't really know why, but it looks like somebody didn't like the features of the ATX connector, like soft power on, soft power off, standby voltage, and so on, because this board is modified to support none of this. So the ATX connector here behaves more like the old AT connector. And there's also an issue here in the corner. There's one resistor that's missing, but I got a picture from one of you guys, which does show clearly the resistor that's missing. So this board needs a new socket, and luckily, a long time ago, I ordered those two sockets, socket 7, and I hope one of them will fit here very nicely. The only problem is we have to remove all these pins. I haven't figured out yet how to do this. Plus, there are still some components in the center of the socket. We have to make sure that these ones stay where they are. I don't want to lose them because it would be very difficult to put them back. You know that I'm working on a Tillamook project right now, so this board hopefully will be able to run the Intel Pentium MMX 300. Peter over at CPU Galaxy used exactly such a board to power a Tillamook version, not the one that I have, but he has the ones with the golden cover. Inside there should be exactly the same chip that I have here, but who knows? Things can still go wrong. Okay, and before we jump under the microscope, thank you PCBWay for sponsoring this video. I'll share a few more details of PCBWay services further along in the video. Okay, and here we are with our missing resistor, and also this capacitor here is broken, unfortunately. So this one here is almost clean, this pad. Let's get our broken capacitor off as well. Yeah, it's cracked through the body, the entire body. Yeah, this one has no reading at all. Here is our donor board, and here are already the 103s that I need. I need one of them. Okay, I don't need the other one. Okay, cap is in place. And here's our resistor. There we go. Okay, so our feedback signal is complete. This one should work. And now let's continue to look at our power connector. You can see here there is a pin missing. This is the 5-volt standby power. And if we turn this around, we can see a bridge on, this is the power on signal. And this is exactly what happens when you press a power button on an ATX system, an ATX power supply. The main board registers it and pulls power on low. So here it is basically pulled down to ground all the time through this wire, which means it is always on. Well, now it pays off that I'm keeping these connectors whenever I salvage something from a motherboard. And it looks like there are different types of connectors. So there's a more transparent version, which looks like we will not be able to just pull this pin through the plastic. Yeah, it looks like these metal pieces here will prevent me from just pulling this from the top. This one here, on the other hand, it has the metal piece on the top. So which one do we have on our motherboard? Oh, we have the one where we see the metal piece on the top, so I don't have to desolder the entire connector. That is so much better. Here is our pin. Nice. Now I just have to get this in there nicely. Nice. No need to desolder anything. However, you may have already noticed that some of the solder connections here are broken. So I will definitely reflow those and we'll remove this bridge. Nice. So here's our new pin. Welcome home. So now we need to get rid of this. This would force the power supply to be always on. Oh, it doesn't move. Oh, wow. Somebody wrapped this around. I think this is not a simple... Somebody really didn't want this to come off. There we go. So it was wrapped around the pins. Interesting. Okay. I wonder if you will see problems on this board. I don't think this was a fix, permanent fix from the factory. At least I hope not. I measured already, trying to see if there is an issue with a 5-volt standby power. Like, is it shorted? Is there an issue? But no, nothing. So looks fine to me. I think we can safely undo this mod. Okay, so now we added our new pin. We removed this bridge. Now just clean this up. And then we can try to maybe power this board on and measure some voltages first before we do anything else. And I think this is a good spot to thank PCBWay for sponsoring today's video. PCBWay is a one-stop shop for all your project needs. If you need PCBs, PCBWay has you covered. Prototyping, advanced PCBs, flex and rigid flex, and much more for hobbyists or full production runs. Transform your breadboard design into breathtaking PCBs. It isn't that complex. I did it myself. All my projects are available on PCBWay's shared project space. So if you don't have time to design your own, you can pick one of mine, or from the thousands of other projects that are available over there. And if you don't want to assemble the PCBs yourself, you can always ask PCBWay to do it for you. Beyond PCBs, PCBWay offers a comprehensive catalog of manufacturing solutions to bring your projects to life. CNC machining, 3D printing, sheet metal fabrication and injection molding are the diverse range of services that makes PCBWay your true one-stop shop. So, if you need a partner for your next projects, make sure to check out PCBWay.com. Links are in the video description. Okay, so before we continue, I want to see if this board actually does something. I want to see if it powers on and if we get the correct voltages. So yeah, let's plug in our power supply. I have no idea what to expect right now. Absolutely nothing. We reverted all the mods that were on this board. I already plugged a speaker and a switch. I think it would be good to have a LED here, at least a power LED, to figure out if the board is actually on or not. And let's plug in our power supply. Let's hope nothing bad is happening. Okay, so power is there. Let's see if our LED switches on when I press the button. Okay, the power supply switched on, but the LED didn't switch on, I think. No. Oh, okay. Okay, the power LED is actually one of these that needs one spacer in the center. So let me see if I have one. This is just a 2-pin. My bad. Okay, I built quickly a 3-pin version. And now hopefully this should turn on when we power on the power supply. No? Okay. It doesn't turn on. Interesting. Okay, let's see if we get CPU voltages. At least, you know, the board is working. Let me see if I can probe one of these pins. This one here should be 2 volts. I think this is VCC 2. 2 volts. Okay, so this is great. This is our 2 volts. And over here on this side, we should have VCC 3. 3.3 is the 5th from the top. 1, 2, 3, 4, 5. So there are more of them. So this one here should be 3 volts. But we're getting 1 volt. So that is not okay. It might change if we have a load on it. Oh, okay, I'm a little bit confused with this board. It looks like ground is not connected to this pin where the LED is connecting to at all. I have no idea how. So if I close the circuit now I'm bridging to ground through my multimeter and my LED is going on. And it takes around 13 milliamps. So that's actually correct. Okay, I really don't know what else to do. I think we just continue and replace the socket, and hopefully we will see a change once a CPU is in that board. Maybe it needs just a load to enable all that circuitry. I want to try and heat from this side the pin and then just see if I can pull it out. Let's see if we can plug these pins one by one. Okay. Okay, so they're flying. But I think this is the best way of getting rid of these. I think I have to start from one side and then just go one by one. Here you go. So this is how one of these pins looks like. I think this is the easiest way and probably the one that doesn't cause too much stress on the board. Now here we have a big copper plane. These are the worst ones, most likely. Okay. So there will be a few challenges. Let's just add a little bit of flux. This is never bad. And let's add a little bit solder. Then we are transferring more heat. And then, oh. And then it should be easy to get these ones out as well. There you go. So yeah, it is possible. Yeah, and like this. I'll pull now every pin and make a pile of these ones. So when I use my desolder station later, I'm probably also using hot air to heat up the board. Otherwise, I think this is impossible to do properly. The hot air station can't just heat up the surrounding area of the board. And yeah, that makes it easier to suck out the solder that's hiding inside the board right now. So yeah, if you enjoy the ordeals that I'm going through trying to repair old hardware, like this video. And if you have not subscribed to my channel, maybe now it's a good time to do that. You can already let me know in the comments. Maybe, you know, take a bet if this board is going to work or not. With, I don't know what we'll use. I think I have to use a Pentium MMX 233. I think this is one of the CPUs that I have the most. Like I have really maybe 7 or 8 of those. I'm actually no longer taking them when I find them at the scrapyard because there's no need. But all of this only to maybe get this Tillamook to work. And I know that this board worked for Peter. That is why I'm so after trying to get this board to work. Okay, so we are ready to test the system. I decided to use a 3.3 volt CPU the system is now configured. The board has 66 megahertz FSB. It has 3.3 volts for the IO, 3.3 volts for the core, which this CPU is rated for. And we have a multiplier of 2.5 to get the 166 megahertz. So, and let's try our new socket. Yeah, here's the notch. And perfect. Okay. So I don't have any cooler here right now. It will be my thumb. We'll just figure out if this board is posting. I have a post card here, no graphics card, but we have a beeper here. So hopefully we will hear some beeps. Let's see. And look at this. We have our power LED on. Oh my goodness. I think this board works. Oh, what a struggle. Before I do anything else, I want to see what voltage we get. So this is the voltage now from our voltage regulator. Let's just see what we get. 3.3 volts. Okay, so if we can get this down to something lower, would be amazing. Now, of course, it would be nice to measure the I/O voltage on our CPU. Now I have an easy access through these pins on the top. So let's just see. I think this one here was our I/O voltage, one of these pins. I don't remember exactly, but let's see. Yeah, and we get 3.3 volts. So the 1 volt that we have seen before was literally because it wasn't populated. All of this effort was worth it. We have a working ASUS P5A-B in revision 1.3. This is a single voltage plane CPU. Even if we have configured 2 different voltages, this CPU is connecting both planes together. So what I will do now is I will switch this CPU out and we'll get a Pentium MMX, because Pentium MMX definitely have dual plane voltages. So let me put a Pentium 233 in there, and then we should get 2 different voltages. We should get 2.8 on the core and 3.3 on the I/O pins. Okay, and here is our Pentium MMX we are going to use. This one unfortunately has a scratched heat spreader, but here we can see it is a 2.8 volt part. So this one here definitely has split voltages. I configured this board now for 2.8 volts on the core. So let's see what we get. So 1, 2, 3, 4, 5. 3.5 volts. Okay, that is very high. This is what I was worried about. The problem is that this board actually delivers 3.5 volts on the I/O pins, and this is specified like this in the manual. I want to get this down to 3.1 or 3.0 volts. Tillamook safe. 3.5 is, for me, too high. This is basically 1 volt over the specification that Intel gave it. So I want to get this board 2 volts on the core and 3 volts on the I/O pins for the Tillamook test. Now let's see core voltage. I think core voltage is somewhere here. Yeah, and we're getting 2.8 on the core. We saw both voltages, and that is great. Now let me set up a full system with graphics card and everything. And then this is it for this video. The next one that I will do regarding this project will be figuring out how we can mod our power supply and get the I/O voltage down to a lower value. Okay, let me quickly set up the system and then we'll have a look what BIOS version this is. Okay, we have revision 10.10. I have a problem with the keyboard as it looks like. Okay, my keyboard doesn't work. Let's hope this is not a big issue. Let me just try again. Okay, now the keyboard works. Okay, that's good. I don't know what happened, but now it seems to be working. I may have to check what's going on around the connector for the keyboard. I feel like I moved it and it started working. Not sure. Yeah, now it works fine. So what is so interesting about this board? Big question. So we have the P5A-B as seen on the top. So that's great. minus 5 volts error. Yes, it's an ATX power supply and it doesn't have the negative 5 volt rail. So that is okay. Now the CPU seems to be a bit toasty, to be honest. At 53 degrees. I have a cooler fan on it, so maybe there is an issue with the 3.5 volt I/O. It does sound a little bit high, but vCore we can see is at 2.8 volts. That's great. PCI setup, yeah, so this is all standard stuff. I think there is nothing we have to do here. I'm just checking now which BIOS we have available on the RetroWeb. We have 1010 and there seems to be a 1011 available with audio, without audio. It's a beta BIOS. So it is on the latest version. I don't think I want to update this to the beta version. I want to keep it as is. This is the last final version, not a beta BIOS. Let's quickly check system information. Yes, so we have a Pentium 166. Benchmarks, so we get 567 points. We have 64 megabytes of SD memory on this board. Memory bandwidth 182 megabytes per second, and we have the Tsang Labs ET6000, which has a total of 2 megabytes of video memory. So we have 16 kilobytes of level 1 cache and 512 kilobytes of level 2 cache. Yeah, this is all I wanted to see. So the caches are working on this board. And the tests are complete. So we have this as a reference. This is a Pentium 166 MMX. Technically it is a 233, but I downclocked it because of reasons. Okay, so I think this video is long enough. Let's keep it at that. Thank you so much for your time. Thanks for watching. I hope you enjoyed this. And well, we have a working ASUS P5A-B, which hopefully supports our Tillamook, the one that I fixed in my previous video. Yeah, if you don't want to miss this, subscribe to the channel. Please like the video if you enjoyed this. And if you want to support the channel, either head over to Patreon or become a member here on YouTube. Thank you again for watching, and I will see you in the next video. Take care and bye-bye.